So this lecture is to replace the live office hours from October 1st because I forgot to hit record on them. And so I'm going to go over what I went over in those live office hours, and that is absolute value equations and inequalities. So we're going to start first with equations. So the big thing to remember is that for equations, the word equations means you have an equal to sign. And your answers should be of the form x equals some number. So that's just a little tidbit to help you out on the test, because on the test there's going to be equations and there's going to be inequalities. And so equations are always just numbers are the answer, just like one or two single numbers. So for absolute value equations, for absolute value in general, so absolute value is a mathematical way to measure distance. So absolute value is talking about the distance from 0 on a number line. So if we have something that says the absolute value of -5, so what that's saying is, if you think about on a number line, here's 0, 1, 2, 3, 4, here's -5. So if you think about the distance from going from 0 to -5, to get out here, I'd have to move 1, 2, 3, 4, 5 places. So that's why the absolute value of -5 would be equal to 5. Absolute value of 5, so 1, 2, 3, 4, 5, is also, if I go out here to 5, right, I have to move again 1, 2, 3, 4, 5 spots. So the absolute value of 5 is also 5. So absolute values turn out to be positive, because if you think about, if you pulled out a ruler, right, or a measuring tape, and you looked at it, on your ruler or measuring tape, all of the numbers are positive. And so we don't measure things with negative numbers. So that's another reason to think about when you were dealing with absolute value, all of the stuff inside the absolute value after we take the absolute value has to turn out to be positive. So when we're trying to solve something like this, so example A, the absolute value of x equals 5. So as we saw above, if I want to go 5, I could go 5 to the right, or I could go 5 to the left, which means my answers would be there's a positive one and a negative one. So x could turn out to be positive 5, or x could turn out to be negative 5. So let me get rid of that. I don't know, let me see. Oh, there we go. So every time we think about absolute value, we want to think about distance. So let's try another simple one. So for instance, B, the absolute value of x would be equal to, say, 12. So we're talking about things that are from 0, 12 away. So you could go 12 this way or 12 this way. So if you went 12 to the right, you get to positive 12, and 12 to the left, you get to negative 12. So again, you get these two answers. You get you get x is equal to negative 12, x is equal to positive 12. So again, I have a negative part and a positive part. You can sometimes see problems that start off like this. It'll say the absolute value of x is equal to -7. And so this is asking the distance to what things is negative. But again, remember, distance can't be negative. So distance isn't negative. So what that means is this absolute value of x equals -7, that has no solution. So there isn't an answer that gives you that. So this is how some simple absolute value problems can look. Of course, most of the problems we do are not this simple. So let's look at some harder ones. So for instance, I think we're on part D now. Let's look at the absolute value of x plus 5 equals 6. So here, in this case, I happen to have a lot of stuff inside the absolute value. So I'm just going to worry about basically the absolute value being equal to 6. So we know that on the number line, right, here I am at 0. If I go 6 this direction, I'll end up at -6. And if I go 6 this direction, I'll end up at +6. So this is going to split into two problems. So that negative problem, that positive problem. So you're going to be equal to -6, or something's going to be equal to +6. Now in the last problem, it was just x, because x was the only thing inside of the absolute value. But here, inside the absolute value, I have more than just x. I have a bunch of stuff. And so what I'm going to do is I'm going to take all of this stuff and set it equal to these things. So x plus 5 would be equal to -6, or x plus 5 equals +6. And then I'm going to solve each one of these. So I'm going to subtract 5 from both sides. So in this case, x is equal to -11. And I'm going to subtract 5 from both of these sides. And so x is equal to +1. So my answers here, I have two answers. They are -11 and 1. And notice, one of the answers here, it happens to be negative. And that's okay. A lot of people get confused because they think the answer to an absolute value can never be negative. And that's not the case. What is the case is whenever you have an absolute value of a bunch of stuff, that absolute value part has to be equal to a positive number. So your goal in solving the absolute value problems is to get it into this form. We want to eventually get to the absolute value of a bunch of stuff equals a positive number to be able to solve it. So for example, here's another one. Let's say I had the absolute value of 2x minus 1 plus 3 equals -1. So again, this problem is not in this form yet. So I want to get the absolute value to be the only thing on the left-hand side. So if I look at this problem here, I have this +3. So the first thing I'm going to need to do is move this +3 to this side over here. So the way that we're going to do that is we're going to subtract 3 from both sides of the inequality. So in this case, we're going to end up with the absolute value of 2x minus 1 being equal to -4. So now we're at a point where we can look and we can say, okay, I have the absolute value of a bunch of stuff. The absolute value is all alone. And I want the right-hand side here to be positive. So is this right-hand side positive? No, it's got this negative right here. So this is another problem that has no solution. So let's try one that actually does come out to have a solution. So let's say, I'll stick with the absolute value of 2x minus 1 plus 3. But how about this time this is equal to, say, 12. So again, I need to get the absolute value part all by itself. This +3 is on that left-hand side with the absolute value. So the first thing I'm going to do is subtract 3 from both sides. So we're going to end up with the absolute value of 2x minus 1 being equal to 9. And now I have that right form, right? I have the absolute value of a bunch of stuff, and it's equal to a positive number. So I'm going to split it into two problems. So we're going to have the negative side and the plus side. So we're going to have 2x minus 1 is equal to -9, and 2x minus 1 is equal to +9. So we'll add 1 to both sides. So 2x equals -8. Divide both sides by 2. X ends up being equal to -4. Again, we'll add 1 to both sides. 2x equals 10. divide both sides by 2, x ends up being equal to 5. So, again, I get two answers. My two answers here are -4 and 5, and those are both okay. We'll do one more example here. So one that's a little bit more complicated. So maybe something like 4 plus 3 absolute value of x plus 2 is equal to, we'll say 7. Sounds like a good problem. So again, I need to get this absolute value all by itself. So if you look at it, the things that are happening to the absolute value, it's being multiplied by 3, and then this 4 is being added to it. So the first thing I'm going to do is I'm going to subtract 4 from both sides of the equation. So we're going to end up with 3 absolute value of x plus 2 equals 3. And now, if you look, this 3 is being multiplied times this absolute value. So I still need to get the absolute value all by itself. So I'm going to do the opposite of multiplication, which is division. I'm going to divide both sides by 3. And so now I'm going to have the absolute value of x plus 2 equals 1. And now I'm in that scenario again where I have the absolute value of a bunch of stuff is equal to a number. And so if I split this, again, into that negative case and the positive case. So this is saying the distance equals 1. So we're saying that x plus 2 could be equal to -1, or x plus 2 could be equal to +1. And so if I subtract 2 from both sides here, x ends up being equal to -3. Subtract 2 from both sides, x ends up being equal to -1. So my answers here are x equals -3 and -1. So both of those are answers. So that's pretty much how the absolute value equations work. So now let's look at the inequalities because they're a little different. So absolute value inequalities . So inequalities are going to be things that have the less than sign, the less than or equal to sign, the greater than sign, and the greater than or equal to sign. And before we do an absolute value inequality, I want to help us remember a couple things about the about just inequalities. So we're going to kind of like pause here while I do an example. So this example is not about absolute value inequalities. It's about just regular old inequalities. So let's say you had the inequality 3x plus 2 is, say, less than or equal to 6. So when we go to solve this, right, we want to get the x all by itself here. So here's where the x is. So the first thing I'm going to have to do is move this 2 to the other side. So I'm going to subtract 2 from both sides of the inequality. So we're going to get -3x less than or equal to 4. And then we're going to divide both sides by -3. Now, I divided by a negative number. Anytime I divide by a negative number or I multiply by a negative number, I have to flip the inequality sign. So my answer here is actually going to be that x is greater than or equal to -4/3. And if we think about graphing that on the number line, so remember in the inequalities, so here's 0. There's not just one answer, there's multiple answers. And so if we think that here's -4/3, right? So to graph this, right, I would put a solid dot at -4/3. And the reason that I'm putting a solid dot is because of this little equal to part here, right? So things here, this equal to one on less than or equal to or greater than or equal to, those get solid dots. And then I want to, if you always get your x on the left-hand side here, this inequality sign will always show you which direction to shade. So this is pointing to go towards the right, so I'm going to shade up here towards the right. And then remember, the answers to inequalities, we're going to write in interval notation. So we're going from negative 4/3, and we're going all the way out here to the right. And so remember, all the way out here to the right is infinity. So we're going from 4/3 to infinity. Remember, infinities always get parentheses, no matter what. The infinity should never, ever, 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 ever have a bracket. It should always have a parenthesis. And then the solid circle, the solid dot, that's the same as a bracket. So this right here would be my answer. So we're going to take the same stuff that we've been doing, but we're going to take it one step further. And what we're going to do is we're going to look at absolute values also with inequalities. So again, the absolute value, remember, represents distance. So if I have the absolute value of x being greater than or equal to, say, 5, I'm talking about all the points that the distance from 0 is bigger than or equal to 5. So if you think about moving out on either side of the number line here, right, so let me count 1, 2, 3, 4. So here we are at -5. 1, 2, 3, 4. Here we are at +5. So if you think about moving out, I want all the things where the distance is bigger than 5. So that would mean I could be here at -5, but I could also be anywhere out here, because as I move out here to the left, that distance is getting bigger and bigger. It's further and further away from 0. It's more than 5 away from 0. Same thing here, when I'm at +5, that distance is going further and further to the right. And so when I go to write my answers, so again, remember, all the way out here is -infinity, all the way out here is +infinity. So this first interval here is from -infinity to -5. I put a parenthesis with the -infinity because infinities always get parentheses. And I'm going to put a square bracket here with the -5 because it was a solid circle. And then I have another piece over here. And so for this piece over here, I'm going to write that. So it would be a bracket again for the 5 because it's a solid dot all the way up to infinity, and infinity always gets that parenthesis. And then the way we put them together is with that U sign, so for the union. So that's the way that the two pieces go together. So again, absolute value inequalities, if you think about them as distance, it can help you out. If you had a less than, so let's say the absolute value of x was less than 5. So if we're talking about less than 5, 1, 2, 3, 4. Here we are at -5. Put a couple more tick marks. 1, 2, 3, 4. 5. So since I'm less than, right, and there isn't, so if you look, here is the equal sign. There's not an equal sign part here, which means instead of doing closed circles like I did up here, I'm going to do open circles. So again, if I go 5 away, that would be an open circle here and an open circle here. So if my distance is less, my distance is going to be in between here. So my distance is in there, and so my interval here for my answer is from -5 to 5, and they both would get parentheses. So the rules for drawing the intervals is the same as the rules for when we were solving the inequalities with the absolute value, like up here. Same as when we were doing the compound inequalities that you might have seen on Alex. Okay, so let's talk about how to solve some of these problems. And so I teach this different than Alex teaches it. I personally like one method that works all the time. So I don't like to have to try to think whether, so if you think here, in this case, so some people when they teach it, they talk about this case as being branching out. So here, right, I branched out to the left, out to the right. And here I'm sandwiched between the -5 and the 5. So sometimes people refer to this as sandwiching. And that's totally fine. And if you like, this is the way that Alex kind of teaches it. If you like the idea of branching or sandwiching, that's totally fine. But I am going to teach you a way that works every single time. So our rules, so the things that we are going to do. So the rules to solve an absolute value inequality are going to be the following. So the first thing is we're going to isolate the inequality on the left-hand side. So just like in the regular inequality problems where we got x onto the left-hand side, or when I solve equations, I tend to try to get my x's on the left-hand side, or when I solve those absolute value equations at the beginning of this video, I got them all on the left-hand side. The first thing I'm going to try to do is get all of the absolute value inequalities on the left-hand side. The second thing we're going to do is, once we have the absolute value inequality all by itself on the left-hand side, we are going to split, wait a minute, before we split, so the second thing we're going to do is we're going to check that the problem makes sense distance-wise. All right, so if you remember when we solved the absolute value equations, we had sometimes that there were no solutions. So some of the absolute value inequality problems can also have no solutions. So we just want to be aware of that. And basically, we're looking for things that look like the absolute value of a bunch of stuff being less than or equal to a negative number. Right? So if you're less than or equal to a negative number, it's saying that your distance has to be smaller than something that's negative, and that's not going to happen. Right? So in this case, you would have no solution. And it's the only case you end up with no solution. You also want to check to see if you have the absolute value of a bunch of stuff being greater than or equal to a negative number. So basically we're looking for negative numbers. And in this case, the answer is going to be all real numbers, because no matter what distance we get, it's always going to be bigger than a negative number. And the way to write this in interval notation would be negative infinity to infinity. So that's kind of like these are two special cases, and we're just going to worry if once we get the absolute value of a bunch of stuff, it's has a negative number on the right-hand side. So most of the time, like 95% of the time, you're not going to have to worry about this part 2. Okay, so part 3, we're going to split into 2 problems. Just like we did, just like the absolute value problems, the ones we did at the beginning of the video. And then what we're going to do, the thing we have to remember is that, so remember, in the negative case, we must flip the inequality. So just like when we divide both sides of an inequality by a negative number, we flip the inequality sign. When we solve an absolute value inequality problem and we have a negative number, we have to remember to flip the inequality sign. So, and then fourth, we're We're going to graph each answer. And we're going to have kind of two choices. Either our graphs are going to overlap, in which case we take the overlap. Or our graphs are not going to overlap, in which case, so if they don't overlap, so no overlap, we're going to take all the parts. And I know this is a lot of words to see what's happening. So we're going to do a bunch of examples. So that should hopefully help things out. So, for example, solve the inequalities. So the first one here. So let's look at the absolute value of x plus 2 is less than or equal to 4. So my absolute value is the only thing on the left-hand side. So we're good with that. This number here is positive, so we're good with that. So that takes care of part 1 and part 2. They're already done for us. So now what we're going to do is we're going to split it just like we did before. Negative case, positive case. For the positive case, everything's going to stay exactly the same. We're just going to get rid of the absolute value sign. So x plus 2 is going to be less than or equal to 4. For the negative case, we're also going to have x plus 2, and we're going to have a negative 4. But remember I said in the negative case, right? Remember in the negative case, you have to flip the inequality. So here's that inequality sign. This is the negative case. So I have to flip that inequality sign. So it flips from being a less than or equal to a greater than or equal to. So now I'm going to solve each of these. So subtract 2 from each side. X is going to be greater than or equal to negative 6. Subtract 2 from each side. X is going to be less than or equal to 2. And now I'm going to draw each of these on my number line. So negative 6 and 2 are my important points. I'll draw this first one here in red. So if x is greater than or equal to 6, we would have a solid circle at negative 6, and we're going to the right. And I like to draw my things up above the number line, just so that it kind of doesn't get too crowded. And then we'll do this x is less than or equal to 2. So if I do x is less than or equal to 2, we're going to have a solid dot at 2. And we're going to go all the way off to the left. And then I am interested, so if you look at my thing here, right? So we're trying to determine, do they have overlap or are there no overlap? So these definitely have overlap. The red and the blue lines overlap each other right here. So that's going to be our answer. So our answer is going to be this part. So the answer is going to be from negative 6 to 2. And because they are closed circles here, we are going to use brackets. So bracket on the negative 6, bracket on the 2. Okay, let's try another one. Oh, did I call this one A? I did. Okay, cool. So we're going to call this one B. So let's look at the absolute value of x minus 4, and let's do greater than 9. So again, if you look at this, the absolute value is all alone. The number on this side is a positive number. So I'm going to split this into that negative case and the positive case. So remember, in the positive case, everything stays the same. So x minus 4 is greater than 9. In the negative case, we have x minus 4. We're going to have a negative 9. But again, because I made this negative, I have to flip the sign. And so this now flips to a less than sign. And those are the two inequalities we're going to solve. So we're going to add 4 to both sides. So x is going to be less than negative 5. Add 4. Add 4. X is going to be greater than 13. And then again, if I draw them on the number line, so we're going to have a negative 5 and a 13. If I draw that first one here in red, x is less than negative 5. So because this is a less than sign and there's not that little equal to part, it's going to be an open circle. So open circle at negative 5. Also, if you notice, the inequality is pointing towards the left, so I'm going to shade towards the left. So we're going to go this way to the left. This other one here, x is bigger than 13. So we're going to have an open circle at 13. And again, we're going to shade towards the right. And so now, if I want to write down, so if I look at my number line here, there's no overlap, which means I have to take all the pieces that I see. So the pieces I see are this piece and this piece. And so those are the two I'm going to write. So remember, out here, you're going all the way to minus infinity. So we're going from minus infinity to minus 5. Infinities always get parentheses. The minus 5, because there's an open circle here, that's also going to get a parenthesis. And then 13 to infinity. Again, infinity gets a parenthesis. The 13, because of the open circle, is also going to get a parenthesis. And we're talking about the union of those two things. So again, if they overlap, you take where they overlap. If they don't overlap, you have to take all the pieces. So let's try a couple more here. So what about C? We'll take the absolute value of x plus 7 minus 6 is less than or equal to negative 3. So again, I can't determine whether or not there's going to be a solution or that no solution until I first get the absolute value alone. So the first thing I want to do is I want to get this absolute value piece all by itself. This minus 6 is sitting here, so I'm going to add 6 to both sides. So we're going to end up with the absolute value of x plus 7 is less than or equal, whoops, forgot my other line there, is less than or equal to 3. So now I can look at it. I've got the absolute value all by itself on the left-hand side. I got a positive number here on the right-hand side, so we are good. So we're going to split it into those two problems, the negative case and the positive case. So x plus 7, remember in the negative case we have to flip the sign, greater than or equal to negative 3. X plus 7 less than or equal to positive 3. So we're going to solve both of these. So subtract 7 from both sides. So x is bigger than or equal to negative 10. Subtract 7 from both sides. So x is less than or equal to negative 4. Draw them on the number line. So I'm going to need negative 10, negative 4. So this first one, greater than or equal to negative 10, closed circle all the way to the right. The second one, less than or equal to negative 4, closed circle, because again, that equal to part makes it that closed circle. Go all the way to the left. And then they overlap, right? There's overlapping, I don't even know if that's a word, but it's happening right here. So we're going to take the part where they overlap. So we're going to go from minus 10 to minus 4. And then because they have closed circles, we're going to put brackets on both sides. Okay, so let's try another one here. What about, oh, I forget what number we're on. C. Okay, so D. What about 2 absolute value x plus 1 minus, actually we'll make it plus 7 is less than negative 11. That works. Okay, so again, I need to get the absolute value part all by itself. So to do that, I have two things that are going on. I have this plus 7, so I need to subtract 7 from both sides. And then I have this 2 times the absolute value, so I'm going to have to divide by 2. So first we're going to subtract 7 from both sides. So I have 2, absolute value of x plus 1 is less than negative 18. And now I'm going to divide both sides by 2. So the absolute value of x plus 1 is less than negative 9. And now, because I have an absolute value of a bunch of stuff, and I have a negative number on the other side, this is where I need to pause and I need to think to figure out, hey, does this make sense? So the absolute value of x plus 1 being less, so absolute value is a distance. So are my distances, and remember when we figure out the distances, they're all positive, are my distances going to be smaller than a negative number? And the answer is no, right? This is a distance, so it will be a positive number. And positive numbers are not smaller than negative numbers. So because of that, this has no solution. So anytime you get those negative numbers, you have to stop and think. The other way it could show up is something like this. So let's say we had the absolute value of, actually, let's write it this way. So suppose we had 12 plus the absolute value of 3x plus 2, and that was greater than or equal to 4. So again, the absolute value part is not all by itself. So I want to get it all by itself. So the first thing I'm going to have to do is subtract 12 from both sides. So we have the absolute value of 3x plus 2 is greater than or equal to negative 8. And now, right, we have that negative here. And so we want to think again. This is a distance. So the distance is a positive number, right? So this whole part here is, okay, so that whole part here is a positive number. And is a positive number going to be greater than or equal to 8? So any positive number bigger than or equal to negative 8? Yeah, that's always true, right? So this is always true. So it's all real numbers. Or another way of writing that is from minus infinity to infinity. Okay, so let me do one more kind of slightly crazy example, or just one that has a lot of stuff going on in it. And let's see, I think that was E. Yep, so now we're going to do F. So what if we did 4 minus the absolute value of 2x minus 3 and is less than or equal to, we'll say 5. Okay, so again, the first thing, actually, I want to change this a little bit. Let's make this negative 5. So the first thing that I want to see is that this absolute value is not all by itself. The 4 is here. There's a negative in front of it. So the first thing I want to do is move this 4 to the other side. And so the way that I'm going to do that is by subtracting 4 from both sides. So if I subtract 4 from both sides, I'm going to end up with negative absolute value of 2x minus 3, less than or equal to negative 9. And now, this negative, I need to divide both sides to get rid of this negative. So remember, we don't usually write it, but this negative is really just saying it's negative 1 times that absolute value. So we are going to divide both sides by negative 1. And because I divided by a negative, I have to flip this sign. Anytime you multiply or divide by an inequality by a negative, you have to flip this sign. So this is going to be the absolute value of 2x minus 3 is greater than or equal to positive 9. So now I'm at a point where I can easily look at my problem now. So if I look at this, I've got the absolute value all by itself on the left-hand side. I've got a positive number on the right-hand side. So now we're at a point where we split the problem, right, into that negative case and the positive case. That positive case is exactly 2x minus 3 is greater than or equal to 9. The negative case, right? Remember, 2x minus 3. We're going to have a negative 9. But in that negative case, I have to flip the inequality sign. So it's going to be less than or equal to. And now we're just going to solve both sides. So plus 3, 2x less than or equal to negative 6. We're going to divide both sides by 2. So x is going to be less than or equal to negative 3. And again, we didn't flip the sign because I was dividing. The number I was dividing by here, the 2, it was positive. So it's only when you multiply or divide, and down here there's a negative. So if I solve this other side, plus 3, we end up with 2x greater than or equal to 12. Divide both sides by 2. X is greater than or equal to 6. And again, now we're going to draw those on the number line. So I've got negative 3, I've got 6. So this first one, less than or equal to negative 3. So solid dot at negative 3 and to the left. This second one, greater than or equal to 6. Solid dot at 6 and to the right. And now if I look at this, right, they don't overlap. So since they don't overlap, I have to take all the parts. So I need this piece and I need this piece. So this left-hand piece is from minus infinity. Remember, infinities always get parentheses. Positive, negative infinities, always a parenthesis. All the way up to negative 3 with a bracket. And then this other part here, so union, because I'm putting another piece with it. Bracket, 6 to infinity with a parenthesis. And so those go together. And so this is your final answer here. Right? So that's kind of a systematic way to do the absolute value problems, to do the absolute value inequality problems. And hopefully that should get you on the right track for a bunch of them.